in last video we have seen Euclid's axiom. Now let us discuss Euclid's 5 postulates. So what do you mean by a postulate? Certain general statements which are accepted without any proof or logical reasoning particular to geometry is called as postulate. So the Euclid first postulate says like this: a straight line may be drawn from any one point to any other point. So let A and B be 2 points. You can draw a straight line from one point to another point. So if only one point is given, how many straight lines you can draw? You can draw infinitely many straight lines through this point, say O. You can draw infinitely many points through this point O. But if 2 points are given, only one straight line you can draw through or from one point to other point. Now the second postulate is a terminated line can be produced indefinitely. You can see through 2 points A and B, and one line segment is drawn through these 2 points. Now this is a terminated line because it has got 2 endpoints. One is at A, another is at B. But you can produce this indefinitely. I can extend this line indefinitely on both sides. I can extend this line indefinitely. So Euclid's second postulate says that a terminated line can be produced indefinitely. Now the third one, a circle can be drawn with any center and any radius. So if C is the center and say the radius is 2 cm, I can draw a circle with any center and any radius. Again here I can draw a circle with center O and radius 1 cm. So a circle can be drawn with any center and any radius. If you have a center and radius, you can draw a circle. Now fourth postulate is all right angles are equal to one another. We know the measure of right angle is 90 degree. So if you draw the right angle like this, say ABC, this is a right angle. The measure will be 90 degree. You can draw the right angle like this also, and if you name this as ABC, the measure of this right angle is also 90 degrees. So all right angles are equal to one another and the measure of right angle is 90 degree. Now Euclid's fifth postulate is if a straight line falling on 2 straight lines makes the interior angle on the same side of it taken together less than 2 right angles, then the 2 straight lines is produced indefinitely meet on that side on which sum of angles is less than 2 right angles. So what does this mean? If a straight line, say we can name this straight line as PQ. So the straight line PQ, it is falling on 2 straight lines, say AB and CD. So 2 straight lines are there like this, and a straight line is falling on this 2 straight lines. Now what happens? It makes the interior angle. We know that this is the interior angle when 2 lines are cut by a transversal. You have already studied that. You have corresponding angles, alternate angles, interior angles, co-interior angles. So all those angles are there. So interior angles means if you name this as O and Q, I can say that AOQ and CQO are interior angles on the same side. So these are the interior angles on the same side of it taken together less than 2 right angles. Less than 2 right angles means one right angle is 90 degree, 2 right angles means 90 degree plus 90 degree, 180 degree. Suppose if you add these 2 angles, the measure of these 2 angles are less than 180 degree, then the 2 straight line is produced indefinitely meet on that side on which sum of angles is less than two right angles. So in simple words, I can say that two straight lines are there and one more straight line is falling on these two straight lines, and two interior angles you take, you add the sum of these two interior angles you take, and if it is less than 180 degree, then if you extend this, they will meet at one point on the same side. It can be this side also, for example like this. And if you take the sum of two interior angles and if it is less than 180 degree, you extend these two sides, it will meet. Now read this. If a straight line falling on two straight lines makes the interior angle on the same side of it taken together less than two right angles, then the two straight line is produced indefinitely, meet on that side on which sum of angle is less than two right angles. So this is Euclid's fifth postulate. So these are Euclid's five postulates. A straight line may be drawn from one point to another point. Terminated line can be produced indefinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another. If a straight line falling on two straight lines makes the interior angle on the same side of it taken together less than two right angles, then the two straight line is produced indefinitely, meet on the side on which sum of angles is less than two right angles. So equivalent version of Euclid's fifth postulate. Euclid's fifth postulate is very significant in the history of mathematics. So Euclid's fifth postulate says that there is no intersection of line or intersection of line will not take place when the sum of measure of interior angles on the same side of the falling line is exactly 180 degree. We have seen that. So if the interior angle, sum of interior angle on the same side of the falling line is more than 180, then these two lines will not meet. And if the sum of interior angles is less than 180 degree, then these two lines it will meet if you extend it. So there are several equivalent versions for this postulate. One of them is famous one is Playfair's axiom. It is given by a Scottish mathematician John Playfair in 1729, and the Playfair axiom is stated like this. For every line L and for every point P which is not lying on the line L, then there exists a unique line M passing through P and parallel to L. So let's see what is this Playfair axiom. So Playfair axiom states that for every line L, let this be line L, and for every point P, let this be the point P, it is not lying on the line L. This P is not lying on this line L, but then there exists a unique line M passing through P and parallel to L. So Euclid's fifth postulate, the equivalent version of Euclid's fifth postulate, which is given by Playfair, is like this. For every line L, there exists a unique point P which is not lying on the line L. There exists a unique line M passing through P and it is parallel to L. You can see that these two lines L and M are parallel. So this result can also be stated in the following form. Two distinct intersecting lines cannot be parallel to the same line. These two are different intersecting lines. We can name it as P and Q, or P already the point is given, R and Q. So these two are intersecting lines. It cannot be parallel to the same line. These two lines, it can be parallel to the same line. So first we have seen the definitions that is used by Euclid, that is given by Euclid. We have seen that point, Then we have seen line. A point is that which has no part. A line is a breadthless length. Then straight line is a line which lies evenly with the points on it. So we have seen Euclid's definition first. Then we have seen Euclid's axiom. Whole is greater than its part. If equals are added to equals, the whole will be equal. If equals are subtracted from equals, the remainders will be equal. So we have seen Euclid's axiom. Then we have seen Euclid's postulate. After that, after Euclid stated postulates and axioms, he used them to prove other result. Then using this result, he proved some more result by applying deductive reasoning. These statements that were proved are called as proposition or theorem. So axioms are the statements which are accepted without any proof. They are universal truths. Postulates are also the statements which are accepted without any proof particular to geometry. They are also universal truth. But the statements which are proved using deductive reasoning or logical reasoning is called as proposition or theorems. So one such example for the theorem is two distinct lines cannot have more than one point in common. If you draw two lines, maximum it will have one point in common. It will not have more than one point in common. If you draw like this, these two lines do not have any point in common. But if you draw like this, these two lines will have one point in common, say as P, and it will not have more than one point in common. Two distinct lines cannot have more than one point in common. So these are about axioms, postulates and theorems. Thank you for watching the video.